So here we are in that gravel pit going down the center of the Bunejug gravel spit, and conveniently they've dug with heavy equipment, dug this out, and I found this exposure, I don't know, more than a decade ago, but it's still here, looks the same. And what we're looking at, these are beach gravels, a stack of beach gravels that are dipping away from us like this, and they're well bedded. There's a certain amount of silt and sand in them, but mostly gravel, up to maybe this size, a few larger pieces right around here. But what's distinctive, or what's unusual about this section is this bright white tephra layer. This is a volcanic tephra. This is the Wono tephra. It was erupted around not 37. It was erupted around 27,000 years ago from probably one of the Cascade cones, is what Jonathan Davis thought. And it's pretty thick. It's 15 centimeters thick, and you don't often find these. But what it's telling you is at the time of that eruption, around 27,000 years ago, lake level was right here. This was the backside of a beach. These beds projected to a crest of a beach ridge that ran north-south here, a spit. Don't know where exactly the crest of it was, but this is around, again, 1205 meters or so. And so it was a pretty, compared to Lahontan when it was at its maximum, pretty small lake. It just encompassed the Carson Sink. But very energetic lake. And why I say that in terms of the wave energy is all these boulders that we see out here, and I'll in a minute show you more of these boulders around here. And we saw some at the last stop, and some of these are this big or bigger. I'm seeing ones that are bigger than a meter around me, and so have to be some pretty big waves. Or another idea is that it could be shore ice. And so at 27,000 years ago, when this was active, if it was cold enough during the winters, you could get an appreciable thickness of ice that would freeze on the surface of the water. And it freezes onto rocks in the near shore, at the shore on the beach. And then in the spring, or when it's melting or whatever, and winds shift, or it can raft those boulders, move them along the beach. And so that might be a viable mechanism for how all these huge boulders, huge for beaches anyway, got out here. More than a kilometer, maybe as many as 2, I forget exactly, but it's a ways that direction, is where the nearest bedrock is, where these boulders were plucked. And these aren't, just some, sort of light 2.65 grams per cubic centimeter granites. These are basalts, and so they're like 3.0, a little bit denser than that, so pretty heavy rocks to move around. And so if it was ice that moved these things or contributed to moving them, you might be able to figure out, well, how thick would the ice have to be to raft the boulders of this size? And maybe someone's figured that out. I haven't looked at the literature enough to know, but that would be a pretty cool thing to try to figure out. And once you knew how thick the ice is, then you could ask the question, well, how cold would it have to be to get ice that thickness? And that would give you some sort of temperature estimate of this point in 27,000 years ago in the late Pleistocene, when this landform and deposit was forming. I think that's pretty interesting. So another really interesting thing about this particular tephra, the Wono, it's one of just many tephras that are found out here. There's some really old ones like the Bishop, 760,000 years old. There's Lava Creek B, which came from Yellowstone. The Bishop came from Long Valley, down by Mammoth. Lava Creek B from Yellowstone, 620 or so. There's the Rockland, 575 or 600, and There's a bunch of younger ones too in the last lake cycle, like this one is the Wono, there's the Carson Sink bed, there's the Trago Hot Springs bed, 23,000, but it's not found in this part of the basin, only in the Pyramid Lake and Black Rock Desert areas of Lahontan. And there's also the Mazama is out here everywhere. That's about a 7,500 year old guy. And it's sibling, the Soyawada, which is about 50 years older than the Mazama, but came from Crater Lake as well. So back to this Wono tephra. Turns out that you find this Wono tephra in a bunch of places. I have found it in a bunch of places in the Carson Sink, as well as over in the Black Rock Western Subbasins area. But this particular outcrop is important because this marks where lake level was. And I'm just going to say it's 1,200 meters. So if this is at 1,200 meters, this is where the lake surface was, right here. And then if you found another Wono that was at 1,195 meters, you could say, well, that was deposited in 5 meters of water. And you could look at the sedimentary features surrounding that tephra in the paleo depth of 5 meters water and just kind of figure out, well, what kind of structures do you see in our, should be the structures that are indicative of 5 meter deep water. And so, and if you find one at 1190, you can say this one was in 10 meters of water. What do I see surrounding the tephra, both below and above it? And so I've done that. A paper I published in 2010 talks about that very thing, using this tephra and the Trago Hot Springs tephra as these isochronous stratigraphic markers that you could kind of delineate what was happening on the landscape at the instant that these tephras were deposited. Because these guys are thought to be erupted in a matter of hours to days, deposited in a matter of days, weeks, months, maybe up to a year or so. And so essentially they define this isochronous represents an isochronous sort of timeline. It gives you a snapshot of what is going on in the landscape at any given time. So they're quite useful that way. And what else do we want to say about this? Well, let's look at some of the boulders just before we do anything else. So there's some up in this, those outcrops right above us are some pretty large boulders. And so is it just straight wave energy, or was there some sort of shore ice kinds of thing going on? And I suspect the latter, but I haven't done too much with it yet. So right here in front of us, you can see that the beds are dipping from left to right. These are the back sets of this spit. And why, or it was a beach ridge spit, kind of. I use a lot of these terms a little bit interchangeably when I'm sloppy. Why I say that the back sets, though, is they're dipping from left to right. The main part of the body of the Carson Sink is off to our left. And that's where the wave energy was coming from, and so these have to be on the back. It had to have been deposited on the back side of the beach ridge. Onward.